Okay, so in this video, we're going to discuss piecewise functions again. However, instead of graphing a piecewise function, we're going to actually take a graph and write out a piecewise function. So what we have here is a typical piecewise function graph. Now, here I'm only using one quadrant, but I still have my y-axis. I still have my x-axis. Because of the type of graph it is, we only need the one quadrant today. And this is basically a graph of the comparison of height in feet over time. This could be, as we recorded, maybe a student on a jungle gym outside of an elementary school, or a play set trying to climb up and get to the very top. It could be a kid climbing up a tree and how long it took him to get to different levels of the tree. It could be one of many different things. But the reason it's called a piecewise function is because instead of being one specific function where you have one continuous line, it actually has little pieces put together to make one function. Like if you notice here, I have 4 different segments here. And we're going to put the 4 segments together to make one line or make one piecewise function. So how do we do this? All right, well, if you watched the last video on how to graph piecewise functions, you kind of know how it's already set up. So we're going to kind of go into that mode and set it up, and then we're just going to simply figure out what the equation is for each line and what the limitations are, or the domain at the bottom, which tells us like our parameters, like how long the line actually is. So we'll do y today. We can usually do f of x. You know what? We'll do f of x. Why not? Because I think you're going to see f of x most of the time. Or in this case, they might have used h of x because it's height over here, but it doesn't really matter. I'm going to draw our bracket in. Now we're just going to simply go through, and we're going to actually have 4 pieces of information here, one for each line. Let's see, the first line is blue. So this bracket basically means f of x or y equals something. So we're going to write the equation, and I like to write them in slope-intercept form because, in my opinion, it gives you the most information when it comes to graphing. All right, so we got to figure out the slope of the blue line. And the slope of the blue line is nothing more than your rise over your run. So when we go from the start of the line, we're going to go up 4, that's our rise, over 1. So it's going to be 4 over 1, or 4. And we put our x. Simple as that. We went up 4 over 1. Now, do we really have a y-intercept? Yes, we do. The y-intercept is 0. So I could put plus 0 on here, but we really don't need to. We don't need to put plus or minus 0. So you're going to see it left blank like that. Now, if I was to leave it at just f of x equals 4x, that means that line keeps going and going and going. But it doesn't. It actually has a stopping point. It stops at 2. So the starting point, the lowest point, is 0. Does it include 0? Yeah, it starts at 0. It's going to include 0. So we'll put 0 is less than or equal to x, which is less than, and there's a blue dot on 2, less than or equal to 2. There we go. So we have our first line, our first subfunction of our piecewise functions. Remember, these are called subfunctions, and those are our domains. All right, well, that first part was easy. Usually is when it actually touches the y-axis. This one might be a little bit more tricky. So once again, we want to come up with a slope for the green line. So we're at 4. We go up to 6. It means we go up 2. And we're going to go over 2. So if I go up 2 over 2, my slope is 1. I'll put the x there. But I don't really need the 1. Because the coefficient out in front just basically tells you how many x's there are. Now, we have to put the y-intercept here. Now, if I had done this on graph paper and I had a ruler, I could match this up and probably line up exactly where it crosses the y-axis. Or if this part was a multiple choice question and I had several different options for my y-axis, I could probably figure out which one it is based on the direction it's going. But I don't have that option here. So what I'm going to do is I have the slope, which is 1, and I have 2 different points on the line. I have 2, 4, and I have 4, 6. So I have 2 points on the line. So I'm going to use the point slope formula because I have a point. I have 2 of them actually, and I have the slope. And that will allow me to figure out exactly what the equation is. All right, so point slope is y minus y1 equals m x minus x1. Now all I'm doing is plugging in 1 point and the slope. So let's choose that one. Either one will actually work. So this is going to be y minus my y value, which is 6, equals my slope, which is 1, and x minus 4. Now normally if I was solving this, I would distribute the 1 to both of them. But if you distribute anything times 1 just remains the same. So nothing happens on the left. And now I'm just left with x minus 4 on the right. Because 1 times x is x, 1 times negative 4 is negative 4. Now, I wanted to say y equals something. So I'm going to move this 6 over. The opposite of subtracting 6 is to add 6. That allows me to cancel that part out there. Whatever I do to one side of the equation, I have to do to the other. So that gives me y equals x plus 2. So I already got my x. I was just looking for the y-intercept, x plus 2. There we go. Now let's erase the equation or the calculation so we have more room. Put this over here. And now I need my limitations. All right, well, the lowest point is it's 2. Oops, off camera there. The lowest point is 2. All right, so we'll put 2. But is the dot green on 2? No. So we'll say it's x is, or 2 is less than, not equal to, because equal to would be the blue, x less than or equal to 4. Because if you notice, my green line goes from 2 to 4. That's part 2. Let's do part 3. All right, once again, we got to figure out the slope. So if I go up 2, and I go from 4 over to 8, I go up 2 over 4, which is the same, up 2 over 4. My rise is 2, my run is 4, same thing as 1/2. 1/2 x. Now it's probably going to be, if I follow it through, it's probably going to be 4. All right, but let's just double check. So let's use point slope again. Y minus y1 equals m x minus x1. And we can figure out whatever the rest of the equation is. We could have actually done this for the entire equation once we figured out the slope. So let's use 8, 8. Because that's a point on the line. So y minus 8, because that's my y value, equals my slope, which is 1/2. X minus my x value, which is also 8. And it's solid. If I distribute this side, that 1/2, using the distributive property, 1/2 times x is simply 1/2 x. We already knew that. We have that much already. That's not the important part here. 1/2 times negative 8 is negative 4. That's not the y-intercept yet. It can't be. That's a negative 4. That'd be way down here. We know it's going to cross somewhere up here. And then now, I'll bring the whole left side down. I'm going to get y all by itself. So I'm going to get rid of this negative 8 by adding 8, which will allow that to cancel out. But whatever I do to the left side, I got to do to the right side. And what do you know? Just as we thought, you're like, we? Who's we? You're the only one there. The people out there in video land. Is plus 4. So that's plus 4. Comma. Now my range, or my domain. So the purple goes from 4 up to 8. Okay. My lowest is 4. My greatest is 8. It doesn't necessarily include 4. That was part of 3. But it does include 8. Almost there. One more to go. Alright. The next one I used orange. Aren't you glad we're almost done? Sorry. You got to entertain yourself sometimes. Okay. So once again, we got to figure out the slope. So here we went up 2 over 2. Because we go from 8 up to 10. So we go up 2 over 2. And we go from 8 to 10 again. Then that means our slope is 1. So this is going to be x. We got to figure out where it actually crosses. This is another reason why it's good to use the point slope formula, because I don't have graph paper here. So everything is not like perfect little space in spacing wise. I could kind of eyeball it, but it looks like it's going to be a negative. I think it's going to end up being 0 though. Let's find out. All right, this point right here is 10, 10. We could also use 8, 8. It doesn't matter which point you use. Even though this is not technically included, if we were to continue the line through, all the way through this, it would actually touch that. So y minus y1 equals mx minus x1. Point slope. Our good buddy point slope. All right, and we're going to plug in the information. That'll be my x value. That'll be my y value. And then plug in the slope. Y minus 10 equals, well, wait a minute. If the slope is 1, we already learned the last time, it doesn't change anything. So let's just go right to x minus 10. So we basically eliminated that. Remember, if I put a 1 in there and I distribute it and x minus 10 was up here, it wouldn't change anything with being a 1. All right, so we want to move this negative 10 over because we wanted to say y equals something, or f of x equals something. We're going to add 10 to both sides. And y equals x plus 0. We don't need that. We already have the x in there. So we were right. It actually does come down to 0, although, like I said, my graph's not perfect. All right, and then the limitations here, it goes from 8 to 10. 8 to 10. And it doesn't necessarily include 8. So 8 is less than x, not equal to. And x is less than or equal to 10. And there we have it, ladies and gentlemen. We have taken a graph and we've written out a piecewise function. If you were in my class, we're going to have to do an exit ticket just like this for an accuracy grade this week. I went over this in class, and here is just some additional help for you. All right, once again, if you guys have questions, please ask me in class. If I eventually put this on YouTube, which I might make up a YouTube channel, ask me questions down below, and I'll try to get back to you as soon as possible. All right, have a good day.